All right, so moving on to a new section. This is section 4.4. In this section, we are going to study the second derivative, f prime prime, or f double prime, as we say it, and what it has to do with the graph of the function f. Okay, in this section, we're going to learn about something called concavity, and we're going to also learn another derivative test, the second derivative test, for determining whether critical numbers are minimums or maximums. So let's go over what we know so far. And this is just going all the way back to like chapter 3, right at the beginning. You know, if f of x tells us the function output, as we're familiar with, in other words, the y coordinate of a point on the graph of the function, like in this little picture here, x input, output, the y coordinate here would be f of x. F prime of x tells us the rate of change, right? The rate of change in that output. With respect to the input, which is the tangent slope, rise over run, right? So here in my little drawing, here's a slope, here's a function f, and here's an x input, and here's a slope of here's a tangent line right here, and its slope equals f prime of that x value, right? So that's the instantaneous rate of change. So f prime prime is the rate of change in f prime, right? So with respect to f, that tells us the rate of change in the rate of change. So we've got this kind of rate of change. How fast is the rate of change changing, right? It's the change in the change. We've got this kind of iterative, kind of recursive type of idea going on here, right? And with regards to the graph of f, rather than just being like how high it is or what its slope is, this has to do with something called concavity. Technically, the right word here for what f double prime is really telling us about is the curvature, and concavity is kind of like sign of curvature. Curvature is sort of how curvy is it, more curved, less curved, positively curved or negatively curved, and that positive or negative curve, which is like basically what direction is the curve pointing, that's what the word concavity refers to. Okay, concavity is sort of a binary thing. It's up or down. So we have two cases. Case one, where f double prime of x is positive on some interval. We're going to talk about this happening on an interval. So if we have a positive second derivative on an interval from a to b, okay, what that means is f prime of x, the first derivative, is increasing. We're going to draw a picture of what that looks like. So here's our interval, let's say a to b over here. And if f prime is increasing, that means that the slopes of the tangent lines are going to be getting bigger. Now, not bigger in absolute value, but like bigger as in like to the right along the number line, right? So if you start, for example, with a negative slope, that is quite negative. That is a steep negative slope. So that would be a negative number, pretty far to the left on the number line. So if that slope is going to increase, then it needs to stay negative. Well, if it's going to increase a little bit, it's going to stay negative, but it's going to be less steep. So as we move between A and B, as we move to the right, it's going to be getting less steep. So I'm going to draw the next tangent line sort of about there. And it's less steep, and then the next one would be there, and that's less steep. And then eventually we're going to get from negative, the negative numbers are going to reach 0 and move into the positive numbers, right? So there's the next one, and there's the next one, right? And so what this is showing you is as we move from A to B, the tangent slopes are getting larger, right? The first derivative is increasing. So this might be a curve that looks something like this. I'm going to attempt to draw this so that the curve itself is, meeting those tangent lines. Oops. There we go. Okay, that's pretty decent. Maybe it looks something like that. This is called upwards concavity. You can see the way it curves, the inside of the curve, which is the concave side. The other side would be like the outside of the curve would be like the convex side. But if you look at it from the inside, it's concave. That portion is pointing upwards. So that's the concavity pointing upwards. We call that concave up. So this is what it means. When you have an increasing rate of change, when the tangent lines are getting larger, when the tangent slopes are getting larger, it produces this concave up behavior. Now, the case 2 would be the opposite of this. if f double prime of x is less than 0 on the interval a to b, then that means f prime of x is decreasing. Okay, it's the rate of change in f prime, right? So now if it's negative, it's decreasing. And that means that whatever your tangents start at, let's say tangents start at 0, then they're going to start decreasing. Then they're going to get negative and more negative and more negative. And that's going to produce, these are the points of tangency, that's going to produce a curve that kind of is curving downward. And the concavity, in this case, here is pointing down. So that's called concave down. There's a W. There we go. So we're not really going to be studying how to measure like curvature, more curved versus less curved. That is really like a Calc 3 topic. But we are going to be paying attention to whether the second derivative is positive or negative, and that'll tell us if basically if the function f, the original function f, is curving upwards or curving downwards, concave up or concave down. Now, oh no, never mind. Nope, next video.